Morning, people. We are back with the thing that I was doing last, which I'm now going to remember. Yeah. Right. We can edit this thing. We sent an event and we pick it up in this system right here. Let's see. So what I need to do is we take the graph. The graph is already in here. I have to remove the node that is being covered and add the new node that is being added, and then also add the connections. But that also implies that the node that is being covered, since we have these transitions in both directions, we also have to look at the neighbors of the node that we are removing and removing this one as the neighbor. Otherwise, we'll be pointing to a node that no longer exists. Okay. Let's make this very small. 1 by 1. Let's say chunk size is 3. Okay, this is now our world. So if I place a new block right here, then we have to remove this node. We have to remove the neighboring pointers from these nodes. And then we have to add this node on top and check for potential neighbors. Okay. Let me see. This one is 0, 0, 1. So this is this. X1. This would be here. So this one has 3 neighbors. 119 is this. 125 is this, and 123 is this. Okay. So in each of these buffers, we have to find, oh, it has 4 neighbors. Oh no, this is 1, 2, 3. Yeah, this has 4 neighbors. So we go through this buffer, check all the neighbors, remove this node from all the neighbors, then remove this node itself. Okay. So, entity to remove. Oh, let's call this maybe node to remove. Node entities. Oh yeah, this has to be int3. So that's the, wait, okay. This is the node to add. Then we have to check below that node to remove is this minus. Oh yeah, and this doesn't even exist yet, so put a pin in that. And we say position minus there is no int3 down, but I feel like I've already used that somewhere, so it would make sense to have a global constant. Yeah, here. Let's put that in utilities. Let's call that what do we call that? Int3 constants. It's a bit long, but oh well. Then we're checking this. Public static. Oh, then we need the entities in this assembly. Boom, util. Entities. Oh, I think it's math. Mathematics. One of the two. Yeah, mathematics. Okay, so we have up, down. Let's also do left is -1. Right, +1. And we got forward is z +1 and backward is -1. Okay. In 3 constants up. Okay, and this is plus down. Okay. And we have to try get this. Try get value. Because it might not exist. then we're gonna say private void remove node entity. Remove node to remove. Okay, so now we also need the entity manager here. So do we need the state? I don't think so. Let's just pass in the entity manager. Entity manager. And then we say entity manager get buffer node transition buffer of entity is read only is false. Neighbors. So now we have the neighbors of the entity that we are removing. Now we say for each neighbor in neighbors, we again have to do this. Oh wait, this is read only. But this one is not read only. And node var n neighbors. And in n neighbors, we have to remove. Okay, first we have to find the thing. So we say for int I neighbors length neighbors I if this is the entity that we're trying to remove. Dot node is this. Then we say n neighbors remove at I and break. And that's it. Huh? And then we can just delete the entity. So we say entity manager destroy entity. Okay. That should remove the entity. What is your problem here? But assembly utilize on Unity entities, which uses the Unity collections. Oh. We don't need you. Oh yeah, and then, oh, okay, we can still check first. So if I do this, I get an error. Graph updater system. The entity does not exist. Okay. So we will have to remove the event. We also have to destroy this event. Otherwise, we're just calling this over and over again. State entity manager destroy entity. Oh, yeah, I need the entities, huh? Okay, so we'll do this like so. Entity array. Entity voxel edit event entity. Oh. Voxel edit event entity. And then we say state entity manager get component data. A voxel edit event from voxel edit event entity. And this is our event. And at the end, we can destroy this guy, which should take care of the error. Yes. Okay, now we check. Okay, so the 123 is removed. Yo, Afrazi. Welcome. What am I working on? I am working on a RimWorld type game. And I'm currently building the voxel engine and the pathfinding. Both of which already kind of work, but now I have to make it dynamic so I can add and remove voxels and update the pathfinding graph. X0, Z1, so this is this. And we only have 2 neighbors now. Okay. So this seems to work. So what I've just done is add the functionality that when I add a block on top, you see these lines right here. This is the path for the graph for pathfinding. And when I put one on top, then this node in the middle gets removed. And now I have to add a new node here and then check the surroundings for new neighbors and add that into my graph, and then we should be good. And I'm doing all of this with ECS. Okay, so we removed the old node, and now we can add a new node. We have to say state entity manager create entity. Actually, I think I can copy this from here. was it? Create chunk graph, voxel entity, create entity. Yeah, and we also have to add this voxel data component. So that's pretty much this. A state entity manager, create entity, voxel data component, position is this, rotation is this, voxel type is that. We say state entity manager, add component data. This component. We should do this assertion right at the beginning. So we make sure the node that we are trying to add doesn't exist. Oh, wait, we need this. Position. Position already exists. Okay, and then we add this to our hash map. And then we got our new node. I'm gonna make this into a method to remove voxel below if needed. This is a void. This only needs the entity manager. This can also be static. This can also be static. State entity manager. And this would be add new voxel. This also only needs the entity manager. This is void. This returns nothing. State entity manager. Okay. So we add the new voxel entity, and now we have to check for neighbors. And we already have all this logic here. This would be it. I'm still contemplating whether I would use this system also for initialization. But I think that just adds a lot of overhead. I think the initialization should be a separate logic. But then the question becomes, how do I organize this in a way so I don't have unnecessary code duplication? I probably need a helper class. Because this I would just have to copy, but that's not nice. Okay, let's make a new class. We'll call it voxel entity builder factory creator. Not really a builder. It's also not really a factory. Well, let's call it creator. Don't have a namespace yet. Make this static. And we want all of this. Oh, I already have constants here, which should be int 3 constants. This is left. Int 3 constants, right. X minus 1 is backwards. And this is forwards. Okay, so we take this. And we say public static void at node neighbors. This needs an entity manager and also an entity. And then we have to go steal this method. Put it in here. This would also be static. This also needs an entity manager. And we also need the lookup table. Okay, let's just pass it in. Node entities. Not sure where this is going to live yet. Just have to put it somewhere for now. Node entities. Entity manager, node entity. And we also have to steal this one. Connected flat ramp. Also, we have to steal this one. Static. This can probably be private. Okay, and then we don't need this. We just say voxel entity creator add node neighbors entity manager node entities and entity. And then I can also take this. Make that a method in here, public static entity create node entity. We don't want this. We need the entity manager. And we need in3 global position byte rotation voxel type. Rotation, this type is type, return voxel entity. I'm calling this voxel entity and node entity. I should stick to one. Let's call it node. Returning our voxels into nodes. Create node neighbors. On the other hand, it kind of represents a voxel. And we have this voxel data right here. It would be weird to call it node data. Okay, I changed my mind. Let's call it voxel. Voxel entities create voxel neighbors. Voxel entity creator. Let's also rename this to neighbor buffer. Although doesn't necessarily have to be a, well, when we're talking about a graph, if they're connected, they're always neighbors, even if they're not physically close. Okay, neighbor. It's time to get my wording exact. Voxel entity. What's the entities? Let's just look for node. Neighbor buffer. Can we open this, please? Let's just call this entity. Create voxel entity. Okay. Okay, now here we can say this assert should go here, and then we say voxel entity creator. Actually, let's call this voxel entity creation helper. Maybe that's a bit more accurate. Voxel entity creation helper, create voxel entity manager, global position, rotation, and voxel type. And then this is our entity bush. Okay. And now in our updater system, when we add a new voxel, we just have to call voxel entity creation helper, create voxel entity manager, position, rotation, and type. And then we don't need this. Okay. And now we just have to call voxel entity creation helper add voxel neighbors, entity manager, voxel entity. Oh yeah, here it's still called node entities. The entity. Okay, let's call this voxel entities. Still don't know where I want this hash map to be. It's kind of awkward. Oh well. It lives here for now. Voxel node merger. Oh, this also needs. Okay. This needs this. Voxel entity creation helper. Okay. So now that should be everything, no? Yeah. Okay, I am amazing. Good. Oh, I'm not amazing. Oh, because we are too high. Okay, we have to catch that somewhere. And I think we have to catch that in the placement. Chunk data set. Placement utility. Add block, add position point. Here we have to say we don't know how high this is. Let's pretend this doesn't exist for now. It's a known issue. So let me commit. Adding new voxel and updating graph. All right. Make this chunk bigger again. Should be able to just add new stuff. Very nice. I add slow, we die. Entity does not exist. We have, for some reason, it's in here. Remove. Oh, yeah. We have to say voxel entities remove. Int 3 position. Slow. Okay. Not okay. Same thing. The entity does not exist. It was previously destroyed. Right. Remove node. Wait, what? We're destroying the entity, but we're not removing it from the thing. Okay, voxel entities. Ah, yeah, okay. That's not the correct position. Yeah, this should be it. Okay. Oh, already exists. Okay, this is getting caught. Okay, so it's not perfect. We still have some edge cases to worry about. But like in general, this seems okay. These don't get connected. Oops. Okay. I want to change one thing real quick. Which is these connections. That is weirdly beautiful, but that's not what I wanted. Oh yeah, we also have this. No, it should be good. Okay, so now it's on top of the block, not like weirdly raised. Yeah, good enough. So the ramps don't get connected, which is a problem. But they should get connected here. I want to say this already worked. Let's go have a look. Reload. Here. And we add a couple of ramps. And we save. And then we go here. And load this again. And then yes, we do get the connections. That is odd. We call the same method at voxel neighbors. Voxel data component transitions. Neighbors. Entity manager, neighbor buffer of entity. Try the neighbor to the left. Maybe the rotation is wrong. Let me check that. Wrong scene. No. Does get connected. Oh, no. Does get connected to the lower one, but not to the upper one. Interesting. Excuse me for a moment. Okay. So you're telling me that I leave and when I come back we have more viewers than before? That doesn't seem right. Okay, anyway. We have to figure out why the ramps don't get connected to the upper floor. Try get neighbor. entity manager, voxel entities. Okay, we check if this is a ramp. Oh yeah, maybe this check already failed. So let's see that in action. Slope push. Voxel type slope. Yeah, this is correct. Ramp to upper ramp. We should skip this. Ramp to lower ramp. Ramp to lower ramp? We don't have any ramps. Neighbor offset. -1 is to the left. Down. Ah, yeah, okay, so now we're looking at this block. But that is a flat. So this fails. Okay. Ramp to lower flat. So we go in here. But that also fails. What? Oh, yeah. Wait. We're looking down. This doesn't seem right. No, it does. Because this is on the same height as this. Okay, so we didn't connect to anything? Oh, am I even looking at this from the right perspective? Let me restart. Yeah, I wasn't looking from the right perspective. Okay, let's do this. Okay, so now we're looking to the left, which is here, which we don't connect to. That is correct. Not this, not this, not this. Okay. So now we're looking to the right, which we also don't connect to. Yep. Okay. We return false. Now we look back, which is this. Now we should connect to this one. Ramp to upper ramp, but that's not it. Ramp to lower ramp, no. Ramp to lower flat, no. Oh wait, we should voxel type paper. Yes, ramp. Ramp to lower flat. Oh, we need this case for the ramp. Because this only checks for lower and now we return false. Okay. Oh, yeah, we are. Okay. No, I see what's going on. So currently we are not, we're only adding the neighbor in one direction. So this was already a bug before, obviously, but it was masked by the fact that we checked in both directions, which we still have to do here. So we have to say ramp to same level. Neighbor offset. Is walkable. Try get value. Okay, we have to check if there's nothing above. I feel like we're still missing some checks. Because we also have to check here if there's nothing above. Ugh. And entity manager up is none. Okay. Let's put this into a method and we'll call it has no upper neighbor. We don't need this out. Um, data, global position. No, let's call this is empty or is yeah. Position. So we either don't have this at all, or if we do have it, it's none. That makes more sense. Entity manager, voxel entities. This. And we can get this back into here. It's the same level flat. is walkable. Neighbor. It's empty. Oh, this is already taken. This has to be empty. Let's make this into neighbor position. And we can do the same thing here where we say is empty entity manager, voxel entities, neighbor position plus up. Okay. So for ramp to same level flat, is not a ramp. So we get the neighbor. We check that it's walkable and that it's not. That it's not covered. Actually, I don't think we need this check because we only because we only add nodes to the graph that can be walked on. Oh, but I just realized there's still one more thing since the voxels are half height. Just checking one above doesn't really... We'll worry about that later. But I don't think we need this check. Because all the voxels that we have here are already known to be open. Oh, but that reminds me. There are so many cases, Jesus Christ. if we add something, we have to check if there's something above. We already do this here. Check this with the voxel data. But here we have to check it with voxel entities. Okay, so we do need this method. Is empty. Make it public. Let's put this in here and we say voxel entities, try get value, position. Let's say contains key. Actually, this is all that we need. So it doesn't really have to be a method, does it? If voxel entities contains key, we just return. Actually, you can do this even sooner. No, we can't. Add new voxel. So if there's something above, we don't add this. Wait, where is the part where we delete this entity? Oh, yeah. Voxel edit event entity. That should be here. Okay, so we don't need to check if this is empty. Ramp. It's connected ramp flat. So here we check the rotation. That should be okay, maybe. Okay, this seems to work fine. Okay. That is no bueno. The entity does not exist. Again. Pathfinding gizmo. Oh, somewhere we're not removing the neighbors properly. That is very strange. It's only for ramps. And okay, so this. So this doesn't work. Okay, let's make this small again. Let's make this 2 by 2. And also let. And also maybe disable this stuff. Okay. Slope. So I add this like this. Then I do this. And that works. Fascinating. Okay. This gives the error. Okay, so there is something not right with this. So this should be my... No, this is not my ramp. Ah, here. Slope. Add 111. This has one neighbor. Yes. That neighbor is this one in 120. And this guy has 2 neighbors. Ah, yeah, okay. So what is missing is when we add this here, we add the neighbor for this voxel, but then we have to say entity manager get buffer neighbor buffer of the voxel entities. We don't actually So we have to add the new voxel as a neighbor of our currently existing voxels. The question is, do we have to check again? Do we have to make all the checks? Or do we just say we only make the checks in one direction? So essentially what I'm asking is, do we have like one-way streets? If we have one-way streets, then we have to do the checks again. If we don't have one-way streets, then yeah, checking one way is enough. I think we should check both ways. It's not like it's gonna cost that much. Is read only, yeah. Oh, but if we check both ways, then we have to clear the buffer, or we put these into, oh, Jesus Christ. Could make these into individual methods. Then fuck it. No. Let's just say we only check one direction, and then we can't have one-way neighbors. I think I probably don't need that anyway. Wait. Neighbors for each neighbors. Entity manager, get buffer, neighbor buffer, neighbor entity is read only false. In neighbors and neighbors at vox new entity voxel entity. Okay. Now I do this, and then this is my slope. This now has 3 neighbors, and now this works. Okay. Good, good, good. Now, object this post exception. What? Attempted to access buffer type handle name buffer which has been invalidated by a structural change. How so? Ah. We get the neighbors. We added here entity manager, add buffer, entity. This is our voxel entity, so why wouldn't we get this? Strange. Okay, easy fix. Then we just return this. Yeah. Why wouldn't I be able to get the buffer after I edited? Shit. This also doesn't work. Huh? It's been invalidated by structural change. So we cannot read this on the same frame that we write it? Is that right? That seems very strange. Neighbors. Add buffer. Huh. Hmm. Okay. Then I'm not happy with that. Why can we not read this? Or is it just the for each? Let's actually check if it would be okay with this kind of thing. Length. Neighbors. Apparently, yes. Okay. There's should also be a check for this case. This already works. Okay. So it doesn't like me for eaching on a dynamic buffer that I have created on this frame. That is one weird restriction. But okay. Okay, so this seems all right. Yeah. So what happens if I do this? That also works. Oops. No, I have done something illegal. I should probably catch this. Just lock it and then discard. So we're gonna say if we already have this, then we're gonna say debug log error. This already exists. We want to destroy this and then we wanna just continue. So when I do stuff like this already throws there. Oops. But we can continue. This doesn't properly work yet. This already exists, yeah. Okay. Good. Let's commit this. Letting rams in graph. Okay. So now we have to remove. Actually, we don't yet have remove. I only have replace, which is this. Okay, so first I need a remove option. UI document. Oh wait, no, I do have a remove option, which is it's just I select none and I replace. That is from my remove, yes. So I have to go to. Wait, do I need this? No. This is old news. Block placement utility. Select. If is replacing, then we gotta say if voxel type building block type is none. And if is replacing, then we do remove. Otherwise, we do nothing here. Continue. Huh? Oh no, we just return. So this would be add new block. And then we don't need this. Maybe we can catch this in the beginning. Like here we say if the block is none and we're not replacing, we're not even doing anything. And then we can see here, remove. So we're doing a similar thing. Let's just copy everything. For the chunk, this is the same. But for the ECS, we have to say not voxel edit event, but a voxel removed event. Position, need only position. Voxel remove event. Okay. And then in graph app data system. Let's make this in two different systems. Yeah. Let's call this graph. Oops. Graph of a voxel edit system. And we're gonna make a graph of voxel removed system. Same thing, but different. Why do you not update the name? Let's get out of this. And we say this is gonna update after the remove system. Okay, we really need a better place for this guy now. Let's put it in here. Voxel entity creation helper. Let's call it. Okay. I hate this name, but we're gonna call it Voxel entity manager. And this is just gonna have this as a public static. It's not pretty, but I don't know where else to put it. Voxel entity manager dot this. Don't dispose this ever. Okay, so for this we need the voxel removed event. Voxel removed events on update. Voxel removed events. Oh shit. Not rename this. Voxel ref Voxel entity manager node entities. Oh yeah, this should also be called. Fucking hell. Could you let me rename this? Okay. So in this case, we have to say if this does not exist, then we log an error. Let's try the event, continue. Okay. And now what do we have to do? We have to remove this block from all its neighbors. And then we have to add the voxel below that. So we're basically doing the inverse. We're already checking this, so this doesn't even need to be here. Okay, so what we need to do first is we get all the neighbors. Entity manager. Entity manager. So entity manager, voxel entities. Oh, no, wait. Say entity manager, get buffer, neighbor buffer of the entity we want to remove. Oh, entity to remove is voxel entity manager for entities. This. I need different music. Oh, Kevin Pinkin, perhaps. Not Made in Abyss. Hmm. Don't we have Rising of the Shield Hero soundtrack somewhere? Rising of the Shield Hero. Let's listen to this. Okay. Entity to remove. Okay, so now we have to get the neighbors from all of this. This read only, yeah, I want to say yeah. Then we go through all the neighbors. This is not read only. And then we have to find, we have to do this. Entity to remove, and remove at this. J. Okay, so then we remove the voxel that we need to remove from all the neighbors. And then we just have to destroy it. So we say entity manager, destroy entity to remove. That should be it. Remove entity. Okay. That is all we gotta do. And then we have to re-add the voxel below. And for that, actually, no, I was just gonna say we could just emit the event. Oh no, yeah, we can do that because this won't trigger because the voxel below isn't in this entities list. So yeah, that should be a possibility. So don't need this. We don't need that. We just say entity manager, entity manager, create entity voxel edit entity. And we say voxel edit event position is this position plus down. Oh, but how do we get the rotation? I think we'll have to get it from here. So when we remove a block, we also emit this. Position down. Point plus vector down. To make a new entity. Edit. What's the position? Plus in 3 down. Rotation. We need the world data to do this. Okay, so somehow we need the private, need the voxel world data in here. Don't know how we're getting that yet, but we need it. Voxel position down, and then we need the voxel world data. Get voxel position down. Voxel position 2 and 3. Voxel rotation byte value and voxel type. Okay, so how do we get the voxel world data in here? Voxel world data is created in the world generator. And this I don't want to make a direct connection from the world generator to the block placement utility. So the only option would be an event. Well, it can't be a Unity event, can it? Also, making it a Unity event doesn't seem like a good idea. So it has to be a C# event. So where does it live? I could do something like game object find object of type or maybe I could use a tag, but that's also kind of restrictive. And objects of type all. Get seen. No. That's not cool. But I also don't want to make it static in world generator. That's also kind of dumb. I think my only option is a static class. I don't want to go with dependency injection, and I don't want to go with dependency injection. Then I also have to think about script execution order. I could say I make a iWorld manager. Yeah, let's call it iWorld manager. And then, no, let's call this iWorld generator or iWorld loader. Something like this. Call it loader. And we're gonna say this has an event. Event handler. Of course, we need an event world loaded event arcs. Which is event arcs, which has public world data. World data. Event handler world loaded event arcs. World loaded. Interface. And then I can say in world generator, this is iWorld loader with this event. And then at the end here we say world loaded this new world data. And then in block placement utility we can say this is a serialized mono behavior. Odin serialize private iWorld loader. And then on awake, say world loader, world loaded world data is world data voxel world. And of course on destroy world loader, world loaded. Remove. And then that should be okay. Is none. Argument exception entity does not exist. Voxel remove. Oh. We did not say this at the end. Replace none. Okay, but this heading doesn't quite work. Ah, we are going too low. So in here, somewhere we say just down. But actually we gotta say voxel helper, voxel scale y. It does not exist. Entity. Oh. Are we removing? No, I again forgot to remove it from. Actually, what we should do is have a method that does these things. Voxel Entity Manager, public static void, remove voxel, and we need Entity Manager, need the voxel, and we need the position. Voxel position. And then we can say voxel entity manager, remove voxel entity manager, node to remove, and this. And same thing here. I want to remove this. Mm-hmm. I'm thinking maybe we could actually make this an extension. That might be not the worst. And then we can just say entity manager it's like not perfect. Makes it a little bit shorter. Okay. Does this work now? Yes. Okay. Good, good, good. We're making progress. These don't get connected though. Okay, whatever. Also, not a thing I'm gonna worry about right now. Okay. So this is what I call good enough. Let's commit remove blocks. Okay, so now we have to do this whole thing for the node merger also. We have been ignoring this completely. So in the world generator, we have commented this out, which is very important for the pathfinding. So what we're actually using for pathfinding is this. And obviously when we add stuff, then we also have to update our rectangles. This is gonna be fun. So how's this gonna work? When we start we first create the entire world, and then we create all the nodes, which is this. And then from the nodes, we create the rectangles. We start here, and basically we look in which direction we can extend this rectangle to try and merge the highest amount of nodes. And when we remove something now, this means if we do this kind of thing, then we have to somehow invalidate this entire rectangle. Because there could be any amount of stuff. So if we do this, for instance, and then we could fuck. There's also the possibility that we can merge with a neighboring rectangle. So if we were to say, okay, if we remove something, then we could just say, okay, make this into its own rectangle, and this into its own rectangle, and this into its own rectangle. But then in order to avoid fragmentation, we would have to check neighboring rectangles to find out if we can, in fact, merge with those. Okay. Let's try and start simple. We make this flat. It's actually what's it called? Flat voxel world generator. Give this a serialize field private byte height S1 min 1. Create plane if y is equal to height. Put this at like 5. Oh. This needs to be smaller. Oops. Smaller or equal. Okay, so we have one big rectangle now. So if I remove any one of these, then we get 8 rectangles. No. Well, we could make it 8, but that would be too much. Too many, I mean. We get 1, 2, 3, 4. So we're gonna say we divide this into all of the above, all of the below, and this one strip on the left and this one strip on the right. So we have to find the rectangle. Let's actually make this a little bit smaller so we don't have as many entities. Let's go 3 by 3. So this is our node rect. We have the bottom left and we have the extents. But every node knows its rectangle. So finding that is not a problem. And we also have to take care of all the neighbors of the rectangles. What am I doing with my life? Okay, so this has to go in here, I want to say. When we remove the voxel. So we're gonna say we do this at the end. Before we remove this entity, actually. Remove entity. We have to remember the rect. So node rect is state entity manager get component data containing node rect of VRE. No. And this. Oh yeah, rect entity. Oh, entity. Entity manager. Okay, so we remove that. We destroy everything. And then once we're done with that, we look at the node rect. And we'll have to say entity manager get component data node rect entity node rect break up rect. So now we have the bottom left. And we're gonna, oh God, I have to find the extents in Y direction doesn't change. So let's call this top rect. Top rect width. No, wait. Let's call this top rect extends. And top rect extends Y is the position that plus 1. Right, we are at the top. Fuck. No, let's start from the bottom. That's easier. So we are going from 0 to Z minus 1. The bottom left is the same. So we say top, bottom correct, bottom left is rect, bottom left. Create bottom rect. And then we say state entity manager, create entity bottom rect entity state entity manager, add component data to bottom rect entity, which is new node rect, which has bottom left as bottom rect, bottom left, and ends is bottom rect extends. And then we destroy the old one. State entity manager. Destroy entity node rect entity. So now we got this and remove that. And this is almost correct. Why is this lower? Extends. Oh, because I'm not copying the Y. The Y is rect Y. So let's not call this Y, let's call this height. Okay. So that would be the logic essentially. Now we have to consider all the cases. Oh, and we have to update the containing rects for everything. Good point. What would this already work for this case? Kind of. We'll just have to say that if this is greater than 0, then do we do this. What's a colony builder? A colony builder is a game like Grimworld or Banished or Going Medieval. Essentially any type of game where you start with like a few people and your goal is to build a settlement. So this would be Banished. And when you start, maybe we have something here. Like Gotham, no, not quite. So this would be banished, which is like classic example. You start with very few people and then you build your settlement. It's not really a god sim because it's more like akin to an RTS, because you, the player, are not really in the game. You just control what your people do. What was I doing? Oh yeah, this. And it's more like, so traditionally you would assign tasks and your people have a lot of freedom, so there's a lot of AI involved. So in that regard, it is a bit like a god sim. In that you mostly don't control your people directly. You just set certain goals. Okay, so this works. Now we need the top rectangle. Okay, so we call this create top, create bottom rect. Don't know why it always insists on returning the system state. Entity manager, entity manager. Okay, so now we invert this, call it top rect. So for this, the bottom left is extends bottom left. Let's call this original. From this, we actually only need the position. Original. Extends bottom left. Correct entity. Int 3 remove position. VRE position. Create top rect. Okay, so for this, our extents are z plus 1 and extends y minus this. Yeah. The bottom left goes up. Bottom left y goes up by this much. And that should be it. Maybe. Not quite. Now the bottom is also not showing. Bottom right. Okay, I broke it. Yes, I broke it. Entity manager, create entity. Bottom left extends. Hmm? If extends y is bigger than 1, bigger than... Oh, I think this has to be greater or equal. Yes, okay. Greater or equal. The extends didn't look quite right. Yeah, for some reason now this is very high. Extends. So this is 2. Minus 1. Do you not need the plus 1? No, we do need the plus 1. We do need the plus 1. Okay. That looks correct. Check if this also works for bigger chunks. Yes. Okay, so now we're missing 2 more. We're missing the left and the right. Create left. So for this, the y extents will always be 1. No, always be 0. And the x will be the x will be remove position x minus 1. Original extends minus. No, wait. If the original extends, then we subtract the right side. We subtract right side, which is extends x minus remove position x, not minus 1. Yeah. And then we say if x greater or equal to 0, then the bottom left is this. And then that should be it, perhaps. Yeah. That is correct. And now we need the right side. Create a right rect. So for this, the extents are the original extents minus the left side. So this is remove position x minus 1. Wait, am I doing this right? You check again. No. Yeah, I didn't do this right. So this is actually for the right side. Remove position. -1. -1. This is right side. And the bottom left. Oh, yeah. The bottom left. X is the it's essentially this. Create right. Okay, done. Replace push. Not quite. I'm back to Made in Abyss soundtrack. Okay, maybe we are done with Kevin Pinken. Okay, one of the two is not correct. I'm gonna guess it's the right one. Okay, this is one too far left. So this +1. Oh, it's also one too wide. So this also needs a -1. Okay. What I could also do is make 4 pieces that are roughly the same size. So I could go like this and like this and like this and like this. Which could have some impact on the pathfinding. Since the larger these rectangles are, the better generally. Now I have 2 smaller ones and 2 big ones. Hmm. Yeah, maybe actually that is smarter. That'd also probably be easier to merge with other rectangles. Maybe. Yeah. Yeah, I think I want to do that. It should be at least just as good, if not a little bit better. So let's start over. We're gonna say the bottom, like bottom left. So we would have the extents do not change in y direction, but extents x is now what's currently the left, but +1. Oh, I didn't press replace. Yes, like this. So the left would then be here. left is not y equals 0. It is now the height of the top rect. Original extends this. And the rest doesn't change. This needs a +1. Like that. Now the top is here. Top rect. So the extends x is what's currently right. +1. That should be it. Oh, yeah, the bottom left corner is origin. Why do I have 2 of this? Bottom left x is remove position x. Yep, okay, this is the right one. All right. So this has extends. Moved position y -1. No, not -1. Just remove position Y. X doesn't change. Bottom left is original. Bottom left Y. X doesn't change, I don't think. Oh, it is too high. Extends Y. Wait. Remove position. What's the height of the bottom rect? Oh, yeah. It's Z. Very important. Okay. Yeah, that looks much better actually. I think that will work just fine. Good. Let's clean this up a little bit. Mm-hmm. So then the next step is to assign all the blocks to their new rectangle. So we would have to get. Could you fucking open this? Is it really so much to ask? Wait. I think we do have a buffer. That contains all the node rect neighbor buffer. No. Yeah, we don't need it because we know all the positions. So what we need to do is find the node merger. Steal this. Let's make this in a method. Private void assign voxel to containing rect. We need some parameters. We need the node rect. And then we say voxel entity manager, voxel entities try. Well, we don't really have to try. They should all exist. New x rect height. That voxel. Then we need the entity manager. And we say entity manager set component data of voxel new containing rect. Node rect is rect entity rect entity. And we do that for all the new rectangles. Assign. Oh, this is. Okay, these cannot be static then. Assign voxels. Entity manager. Rect entity. And we have to remember this. Rect data. Rect data. Rect data. So, and now we should be able to cut all the new rectangles as well. Let's use a bigger one. Almost. 858 is not present. '50s. Could you put me at the correct line? Okay, this should not happen. Yet it does. 858. Eight, 8 does not exist. Can only be the height. But we are 0, 1, 2, 3, 4, 5. Eight, 8. Is that the one I just clicked? 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. That shouldn't be part of any new rectangle. Create bottom rect. This works. This does not. As long as I'm in the bottom left, that's fine. I am left. That's not okay. It's this one. But why? Oh, I'll be right back. So, why does it work the first time and not the second time? This is just fine. Somehow the new extents seem to be not correct. But why would it be correct the first time and not the second time? One 150 does not exist. Hmm. Okay, so we do this. Then we go here. Remove this. Okay. What the fuck? Just go in here. Extends. These X is 1. top rect. Hmm. 13 -1. 14-0? Oh yeah, of course. 14-0. We're looking at this long one. So bottom and top did not get created. Should only be the right one. But we're getting a left. Extends the 0-0. $14-0. $14. 14 -1, 13. Zero. Zero -0. No, something's not right here. The extends. Bottom left. If the extends is 0, and the bottom left is equal to the top right, which makes sense. We're always looking at the center, essentially. So we get a 0-0. Should we get like a -1? -1? Bottom left. I go here, shouldn't get a bottom, shouldn't get a top, should get a left this time with extends. A 1, 0. Left 1, 0. One, 0, yeah. What? What do you want from me? Go away. Fucking hell. Where are we now? Not helpful. We should get a 0, 0 in extends. But why then? Is this correct? Hmm. This somehow looks weird. The left side. The whole width minus the right side. Maybe this should be here. Remove position +1. Does this make a difference? Remove position. Remove position. Z +1. Should be -1, no? No, same thing. I don't get it. Extend. What am I missing? We have a width of 14. No, 15. Width is 15. The position is, we have to get this position relative to the containing rectangle. That's the problem. Remove position. So we need relative position is remove position minus original bottom left. Bottom left. Right. And 3, 0. Original bottom left. Y. That's why the bottom left works, because it's always relative to 0, 0. Not quite. Oh, 1, 0, 5. Now we get 1 here. Now the left right seems to be kind of weird. Oops. This should still be good. Left extends 0, 0. Remove position. Zero, 5, 0. extends. Subtract. Shit. No. Oh no. No, I pressed too many buttons. Hmm. Okay. So we do this. This? Why does this work? Let's check this. We need the left. Our extents are -1, 15. Remove position is 0, 0. Original extents 15. So that means -15 -0 +1. So the right side is 14. Wait, why is this 16? -15 -0. Oh. +1. That should be here, I want to say. And now we have again -1. Which is correct. We have 15 -0. That's the entire right side. So 15 -15 is 0 -1. And now if I do this, we get -1 again, yeah. could you fucking stop? Another right. Why? What the fuck is this? Don't get a bottom. Why do you not go? Create left. You don't get a left. But we do get a right. 13. Original is 14 minus 1. 13. Bottom left is 1, 0. Original bottom left was 1, 0. This is not correct. This should be original extends. X minus, just minus the new extends. Just minus this 13. 14 minus 13 is 1. Plus 1. Left is okay. Right. 14, 0. Bottom left. 2, 0. No, it should be 1, 0. 15 minus 14 is 1. Just this. No. This doesn't work. second time around. Ugh. That's a little bit annoying. Was 14, now it's 13. Bottom left should be 2 zeros. Something is missing here. Oh, wait, we need the original bottom left x plus this. I think that is what's missing. Okay, yes. That is okay. No. Okay, this left side doesn't work. Left. Z. Ah, yeah, okay, because this is now relative. Okay. I need the original bottom left y plus this. Yes. Okay, the top also no needs. Create top rect x original x plus this. Okay, finally. We got this. Okay. So now we need to create actually no, we create the ones on the bottom when we add these nodes. So what we need here is the ability to merge nodes. So for instance, if I do this and that, then these should merge and become one. Also, these should become one. Oh, and I also have to update the neighbors of all the rects. Oh. Oh. Oh boy. So much work. Let's commit this first. Break rect on removal. Okay, so we need to find the neighboring rectangles, which is not too difficult. We already have this here, kind of. We just need to change this so that we put in the rectangles that we want to check. Let's put this in. No. Let's not put this in here. Let's call this rect entity manager. Static. And we don't want the nodes, we want just an array of maybe say enumerable entity, entity rect entities. Entity manager. Each in rect entities at the node rect hash set neighbors. We go through the X and Z. Then we need voxel entity manager, voxel entities. This one. Then we get the neighbors of that voxel. Containing node rect. We get the container of that voxel, and if that container is not the same as the one we're currently looking at, then that is a neighbor. Entity manager, add buffer, current rect. Yes. Let's call this add rect neighbors. And then we call this from graph voxel removed system. Do we call this? Let's just return the entities if they exist. Return rect entity, return default. And then we say bottom, top, it's left and right. Let's make this params and call this that also doesn't really. Break up rect. Wait. Okay. If bottom has value, we need a list list. Entity rects at bottom value private void at if exists. Entity rects bottom top left and right. And then we say rect entity manager at rect neighbors. Entity manager rects. Okay. Now we get our neighbors. More shiny new rectangles. Rect. 2 neighbors. Yeah. Everyone has 2 neighbors. Okay. Good. Okay. We got our neighbors. We got our neighbors. So now we're almost done with that. Now I just have to oh yeah, we still need the merging. So oh yeah, right. We also have to remove the neighboring rects from all the neighbors. Oh, fuck me. Okay, I don't feel like continuing. I'll just leave a note for future me. merge new rects. Okay, so I'm gonna cut it here today. I think I'll hanging out, and I'll see you probably next week. Bye bye.